All right, I'm going to make a video about how I did a conversion from a Mercruiser Alpha to a Volvo Penta SX drive on this hull. This is part of a video series I'm making of doing a turbo BMW inline 6 swap in this boat. But if you're just interested in the outdrive conversion, I'm going to talk about that first, and I'll talk about the BMW stuff after that. Okay, so this is a 1995 Sea Ray 175. Came with a Mercruiser Alpha Gen 2, and I bought the boat with no motor and no outdrive on it. It had the inner transom plate and outer, or the gimbal housing on the back of the boat, but I had the complete outdrive and everything from a 1995 Forester that I wanted to put in here. So I swapped over the outdrive, but I'll show you why I did this and how I did this. But I chose to retain the Mercruiser Alpha inner transom plate rather than using the Volvo transom plate. So you could do this either way. You could, if you had all of the parts from a Volvo Penta SX, you could, the inner transom plate from the Volvo would bolt right up in here, and that would work fine. But there's a few considerations I'm going to talk about why you might want to use one or the other. So the engine mounting points, or the bell housing mounting points for the Mercruiser and the Volvo, are different. I can't remember which way it is, but I believe the Mercruiser, the mounts are closer to each other. So you would have to have the bell housing from whichever inner transom plate you choose to use. And because I'm making this like a reproducible thing, and these Mercruiser drives are much more common, I decided that I wanted to design all of my stuff to be compatible with the Mercruiser stuff. That was one factor why I chose to use the Mercruiser inner transom plate. Also, the Volvo Penta inner transom plate is a little bit different configuration. The Volvo Penta does not use these two upper bolts here. The bolt holes are not present in the outdrive, and the Mercruiser, or the Volvo Penta inner transom plate, does not have this section up here with these two bolt holes. Also, the bottom of this assembly here, this is not present on the Volvo Penta inner transom plate. So the on the Volvo Penta, these bolt holes are here, and the outdrive uses the bolts, but this is not. This is a separate piece. On the Volvo Penta, or at least on mine, this was like a stamped sheet metal piece down here. So this part here, that takes like the reaction torque from the engine, only used these 6 bolt holes here. It did not have the top and bottom ones. But since this is going to be a high horsepower deal, and I wanted to give as much rigidity to the transom as I could, and spread out the loads of the reaction torque from the engine, and just generally be as strong as it can be, I decided that the Mercruiser plate looked to be a stronger piece and spread the load out over more bolt holes, 10 bolt holes instead of 6. So I chose to use this. So those are the reasons I chose it. So the other thing that I had to do had to figure out to do this swap, the steering arms are different between the Volvo and the Mercruiser. They're very similar, but the geometry is slightly different. And this boat actually came with hydraulic power steering, so there was like a hydraulic, power steering ram and everything mounted to this. I did not want power steering. I wanted manual steering, so I chose to actually swap the steering rack and the complete cable and the complete steering column from my other boat into this one. So the mounting points are a little bit different for these. So like the height of this piece where it attaches in here is the same, but the Volvo, the holes that are in this little block here for these bolt pins to go into, the holes are smaller in the Volvo Penta rack compared to the Mercruiser stuff. So I had to take these 2 bolts out, top and bottom, and machine the pins on the bottom of them to fit into this. So that's one consideration. And then also another thing that you're going to run into if you're using the Mercruiser plate with the Volvo outdrive is that the steering arms are not the same. The steering arm is actually shorter on the Volvo Penta. And the angle of this clevis is also not quite compatible. So what I had to do in order to make this work, I actually had to cut the steering arm off here. This is a big piece of like forged steel here. So I cut this arm in half and I grafted in about a 1-inch piece of hardened steel and V-grooved everything out very nicely and TIG welded it all together. And then, blended it nicely and painted it so it looks factory. But that might be a consideration for you, especially if you don't know how to weld, or especially if you're just not comfortable welding something that is a safety critical component. This steering arm, if this steering arm breaks, you're going across the lake at 50 miles an hour, you're going to be, careening possibly to your death. So this is something that, if you're not an experienced fabricator, you might not want to do. So if you are not willing to cut and weld that steering arm, then you're going to be stuck with either taking it to somebody that can modify this part for you. It was not that difficult to do if you have all the parts in front of you, so any reasonable welding shop should be able to figure this out. But I'm not your mother, so you can decide what you want to do. This is how I decided to do it. If you don't want to weld anything, if you want it to all be a bolt-in swap, then you're going to need to use the Volvo Penta inner transom plate, the Volvo Penta bell housing, the Volvo Penta drive coupler that goes on the crankshaft. You'll have to swap all of those parts, as well as have to have the steering rack that's compatible for a Volvo Penta and the cable and steering column and everything. So it's a lot easier of a swap, especially if you don't have like a whole donor boat to take the parts out of. It's a lot easier of a swap to cut and correct the arm on this. So like I said, I had to add about 1 inch to this arm. I didn't take any exact measurements. I just kind of, was just cutting and grinding and welding until it all lined up correctly. Like I said, the angle on these arms are different. So I did have to angle this arm slightly. So I actually just did it in the boat and just I made like a tack weld on here that I could bend and move a little bit until I got it all to line up correctly. And then took it back in the shop and welded it all. I did not take the steering arm out of the outdrive when I did all of this. I did it with the gimbal housing all assembled. So when I TIG welded this, I took like a wet towel and wrapped it around this arm back here to keep this from getting cool and cooking the bearings and seals back there. And that worked fine. There was plenty of room to do all of that. Okay, so then the other thing that needs to be contended with is the hydraulic trim and tilt. The Volvo Penta uses a very unusual fitting for its hydraulic hoses, or at least mine did. Mine is an older Volvo Penta drive that's often referred to as a OMC or SX Cobra drive. So it shares a lot of parts with an old OMC Cobra drive, which Volvo bought the patents to when they designed the SX drive. And the hydraulic fittings on this are the same as a OMC Cobra, and also had an OMC Cobra trim pump. And this fitting here, from the outside, it looks like it's going to be a flare fitting, but it is not. It has an O-ring on there, and then in the ports on the outdrive and the ports in the pump, it has it looks like it's machined for like a male JIC hydraulic fitting or like an AN fitting, but instead of having a tapered flare surface, it has a step machined for that O-ring. So I looked high and low trying to find a fitting that would convert and make this all a bolt together deal, and I could not find anything. So the fittings in here, I should also explain this. So the reason I didn't use the OMC Cobra pump, I could have just used the original OMC or the original Volvo Penta hydraulic lines and pump, and it all would have worked fine. But my pump that came on my Volvo drive was leaking internally. There's like a check ball or something inside of there that was leaking fluid. So if you leave the drive up overnight, the drive would, slowly tilt down over time. Or like when you're driving the boat, the motor would trim itself in from the torque of the prop. And you'd have to keep, bumping the trim out every couple minutes. So that's annoying. I did find some tutorials that you could rebuild the valve body and the pump and replace the check balls and stuff and get it working again and get it to hold hydraulic pressure again. But when I went looking for the parts to rebuild the pump, it was pretty difficult to find any parts for the pump. And I decided that since OMC has been out of business for like 30 years, and their parent, or the company that kind of took over OMC, which is Evinrude also went out of the marine business about 5 years ago. I decided that it was just not pragmatic to stick with with a pump that there are no parts available for. So I decided that it would be future-proofing myself to just convert to the Mercruiser pump. So one option I did find that would have worked, I think. This is a 100R7 type hydraulic hose. That's like a classification of a type of hydraulic hose. And there are 100R7 hose ends like this available. So what I could have done is leave the original Volvo size fittings on this, or on the outdrive side of the hydraulic hoses, and then just cut the fitting off of the pump side of the hose and have a new fitting crimped on here by a hydraulic shop. But anyway, I decided not to do that just because I didn't want to have like proprietary parts that have to be custom built in the future. So anyway, so as I said, this fitting inside of here, inside the outdrive, it is a 7/16 20 thread pitch, which is the same as a -4 JIC hydraulic fitting. JIC hydraulic fitting is the same dimensionally as a AN fitting that you'd use for like a race car. So the threading is the same, the seat is just different. And then on this side, on the pump, these brass adapters that came in the pump, those are a 7/16 24 inverted flare fitting. So they're both 7/16, but different thread pitch and different end styles. So anyway, what I decided to do for the outdrive side here is I just took a -4 male union. So it's a steel hydraulic fitting with, it's the same type of like flare angle as a -4 AN line fitting, like that you normally use for race car stuff. And after kind of studying it for a little bit, I decided that I would try it. The main difference here is that the JIC hydraulic, like I mentioned, a JIC hydraulic fitting has a chamfer on the end of it. So it has like a sealing surface that it's just a metal to metal sealing surface. And you can kind of imagine what would happen if you thread that fitting in there. It will just kind of bite into that shelf that's machined for this O-ring fitting, and it kind of just swages itself into a flare. So I guess that was a little bit risky because I could have really screwed something up in the outdrive there, but I'm pretty good at this kind of stuff. So I just threaded two JIC -4 steel fittings into the outdrive there and tightened them carefully and felt it kind of biting in and making its own, swaging its own flare angle in there, and it sealed up perfect, and that all worked great. So then, like I said, that's just two fittings from Hydraulic Shop that are readily available. These two hoses, these are -4 Teflon brake line that you can order from like Summit Racing or Jegs or any race car shop. These are just pre-made, I think they were 30-inch long -4 fittings on each end. And then this fitting here is the -4 AN flare on this side, and it is a 7/16 24 inverted flare on this side. So that is also a easily purchased part that's available off the shelf. And that all worked great. I've already tested this. I've, basically ran the rams all the way out and held on to the button for 5 seconds and no leaks. And so that all worked great. In order to get the Mercruiser inner transom plate on here, I did have to grind a little bit on the transom plate itself, like just to make clearance for everything. So I ground out here a little bit to leave room to access these 2 bolts. I ground up here to make clearance for, this is the trim tilt sensor wire. And then around here, this big hose here is where the shift cable goes through the transom of the boat. So I did have to grind around there to make clearance. And then one of these 2 bolt holes I had to slot out in order to get the bolts in. But otherwise, the transom plate slides right on the boat. The gimbal housing slides right on the bolt. The bolt patterns for both outdrives are exactly the same. I did not have to cut or grind or modify the transom at all. And then also I don't have it here in front of me, but the exhaust stack for the Volvo Penta SX does fit around the Mercruiser parts, and everything is fine. So yeah, it's actually, if you have all of the right parts and you figure out what you need, it's not that difficult of a swap to do. Like I said, you just have to figure out, the big thing is deciding if you're going to modify this steering arm or not. That's going to decide what parts you need. So that's about all I have to say about the outdrive swap. Now I'm going to talk about what I did to get this boat ready for BMW engine. So as you can see, I made these 2 reinforcing bars to reinforce the transom. So these boats like this, typically like a boat that has like a V8 or, a big block Chevy or small block Chevy or small block Ford or whatever, they'll usually have like a full length transom that goes from side to side, and it's like a 2-inch thick fiber or 2-inch thick plywood with fiberglass inside and out to hold the whole transom is basically trying to flex as the torque or the prop is trying to push the boat forward. So the whole thing is going to try to flex the transom. So since this boat is just came with a little 130 horsepower 4-cylinder, the transom on this is just this little square here. That part is like the 2-inch thick fiberglass, the 2-inch thick plywood with fiberglass inside and out. And then these outer panels here on the outside, that's just like 3/8-inch fiberglass with nothing inside of it. So I decided I wanted to reinforce the transom a little bit, so I made these 2 bars. And then these are my motor mounts that I built. Like I said, this boat was a 4-cylinder boat, and the 4-cylinders have a weird engine mounting system. So they have the 2 mounting pads on the transom that basically hold the motor up and down and keep it from rotating. And then in the front, it just has a single motor mount. And it's kind of like a gimbal that actually attaches to a bracket in front of the crankshaft. So there's just like a single mounting point up here. So that mount in the front doesn't do anything to keep the motor from spinning. It's just those 2 in the back. So like a boat that came with a V6 or a V8, they would have a motor mount on each stringer. But this 4-cylinder boat doesn't. So I made these motor mount brackets. So this is like 1/4-inch plate aluminum, 3 inches wide. And then this is a piece of 6-inch wide extruded aluminum channel that I just got from my local steel supply place. And then these 2 motor mounts here, these are the motor mounts that were originally on the transom assembly from my Volvo drive. So since I wasn't going to be using them, they look like they would be about perfect for what I need for the engine mounts. So I just moved them up here. So to bolt these motor mounts to the stringers here, the floor in this boat, the floor and on the inside of these stringers, like basically what car guys would call the frame rails, is just 3/4-inch marine plywood with fiberglass on the inside and outside of the wood. So, you can imagine to try to attach something like this to 3/4-inch plywood, it's not going to do you very much to try to like screw it into the plywood. Maybe if you use 25 screws in each one, but screws or lag bolts are not going to get a good bite in 3/4-inch plywood covered in fiberglass. So you want to use like a through bolt mounting system. So in order to do that, I cut these 4 holes in the floor on each side with a hole saw. And then that allows me to get inside of there with a socket to tighten the bolt and to actually get the bolt through itself. And then on the inside of the stringer here, on the inside of the fiberglass, there's a big, thick, like 2-inch stainless steel washer. It's the same washer that is on the back side of these mounting brackets. These mounting brackets are also 3/16 laser cut stainless steel that I made and then welded together. And on the back side of the bolt, these bolts go all the way through the transom, and then there's another big, thick, like 2.5-inch diameter, 3/16 inch thick, non-distortable stainless steel washer. So that's all very solid. And so these 4 bolts, like I said, have one of those 3/16 stainless washers on the back side of them. And then before I assembled all of this, I used fiberglass resin on the inside of all of the wood, inside of all of these holes, and sealed up all the wood really good. And then it's hard to see it, but on this bolt hole where these reinforcing bars are attaching to, there is a piece of like 1.25-inch diameter aluminum bar stock that goes all the way through that plate and through the fiberglass and through the wood and all the way out to the other layer of fiberglass on the inside of here. So it's like a aluminum rod with a hole drilled through the center of it in my lathe, about that long. So there's a big, thick aluminum lug in there that's that's a tight fit in the fiberglass and wood that will keep this plate from being able to move forward and back. And then a big stainless steel washer on the inside to sandwich everything together, and lots of this white marine sealant. This is Loctite marine sealant on the inside of all of these washers, on the inside of the bolt holes. Like everything is coated with a ton of that stuff. So all of the wood is protected, and there's no way for moisture to get into the wood through anything. Yep, so I think that'll do good. And then I've already got 2 coats of fiberglass resin coating the wood on the inside of these holes. I'm probably going to give it like 2 more coats of fiberglass resin and fill all of the old screw holes and everything in the floor with fiberglass resin and get all the wood sealed up really nice so that water cannot get into the wood. And then I'll put 2 like aluminum cover plates on these with screws into the floor and lots of sealant on the cover plates. Can't have too much sealant on a boat because water gets everywhere. Yeah, so that'll take care of me for the motor mounts. And then up here, this was a flat floor all the way across here. The BMW inline 6 is a little bit longer than the 4-cylinder, not actually as much as you might think, but it's just a few inches longer. So my harmonic balancer actually comes up to about like right here. It just sits right above this. And actually it cleared the top of the floor without any modifications. So that would have been fine. But what I did find, I am mounting a raw water pump. A marine engine typically uses a secondary belt mounted water pump that sucks water from the outdrive and comes up into the pump and then pumps it into the motor and out into the exhaust. So I decided to use a Mercruiser pump mounted in the power steering location on the BMW inline 6 engine. And in order to fit that pump in here, the pump pulley was actually interfering with the floor, like right here. So the pulley would come up to about right here. So I really could have maybe just notched out this little part of the floor, but I decided I wanted to take this whole thing out here so that I would have more room around the harmonic balancer and more room around this pulley and just kind of make clearance for everything. So I ended up taking like a, what do you call them? Like one of those little vibrating multi-tools, and just cut in here from each end and cut from the top here and just pulled this whole piece of plywood out of here. And then I'm going to take fiberglass resin and seal up all the wood and put new fiberglass cloth over all of this and reinforce all of that with fiberglass. So that'll all get glassed in and painted white so it'll look nice. And yeah, so that's where we are with the engine swap here. The engine has been in and out of the boat about 15 times now. You can see when I put these reinforcing bars in, I did have to bend the bars a little bit to actually fit around the bell housing of the boat, or of the motor. So everything fits in here perfect. And we are ready to go as far as making an engine go in here and run. So as you can see, I've started cutting up the wiring. I have Pro EFI ECU there, battery cutoff switch there, and we are ready to start getting this boat in here for engine in here for real and get her running. Engine is still at the machine shop. I think I'm gonna give up on that tomorrow and just probably put together a stock bottom end 2.5 liter or something like that to get me over until I get a real engine assembled in here. But I don't want to wait. I want to make progress and move forward. So, all right. See you on the next video. Thanks.